So continuing on with our notes, please follow along and take in some extra notes that won't be in your book because once again, there's more information than our new science adoption has for you that you still need to know. I'd like to pick up where we left off yesterday, just a quick reminder of what we're talking about. We got into the section of talking about biomes, and those are the living areas of ecosystems where we have 7 different types that the book introduces us to, and that a biome is an area across the earth, could be on different continents, that have similar climates and similar organisms. Now, once again, a climate we had to look at. That's one of those things that's not really gone over in our book, but we do need to understand and know. Weather is what's happening right now or what's happening this week. Climate goes over usually an extended period of time and often measured scientifically as a year. So once again, we said how Indiana has 4 different seasons. That's Indiana's climate, where Florida has basically 2 seasons, hot and warm, and that's their climate over a period of a year. So then we got into deserts, and we talked about how deserts, they talk about how they have very little rainfall, and scientifically, most of these areas are going to be classified in their specific biome according to how much precipitation they get. But we said we want to change what the book says about being hot and dry environments and just say extreme environments, because I understand that we often think of deserts as being hot with cacti and other creatures like scorpions, but that's not necessarily the case. Scientifically, they can be hot, they can be cold. It's because it's all based on that precipitation. Once again, we can find out that precipitation when it comes to deserts is about 25 centimeters a year, which is almost 10 inches. And so if you remember 10 inches, that's going to be the measurement of precipitation to classify as a desert. Then you'll be good to go on your assignments as well as on your tests. We talked about how it's going to therefore limit the type of plants, the type of animals that you'll be able to find in a desert biome. And then we talked about how it could be hot and it could be cold, because once again, our largest desert biome is Antarctica. We don't think about it being a desert because we do adapt to the idea of deserts always being hot and sandy, and no, it's not the case. It means that it gets less than 10 inches of precipitation in a year's time, and Antarctica definitely classifies it that. So now our new information. And then we get into grasslands. When we talk about grasslands, we often think about Indiana being a grassland, but we're really not. Because scientifically, when it comes to grasslands, then we don't have a lot of trees. That's the biggest difference. When I go further out west, before I get to the desert biomes of North America, then I go from areas where I see a lot of trees to where I get less and less trees. You get out into Kansas, you have a lot of flat, open grassland. Gets kind of boring to look at, but it can be pretty for sunrises and sunsets. We have all of these different grasses, and so sometimes we talk about the prairies or savannas or meadows, but they are just these large regions where, because there isn't a whole lot of precipitation, so when we're talking about grasslands, we're talking about large open areas where they have a lower amount of precipitation. So once again, biomes are going to be based on their precipitation. Deserts get less than 10 inches of precipitation in a year. The grasslands get about an average of 24. So it's going to be more than 10, but it really doesn't go much beyond the low 30s. Now, if you and I were in Indiana and in a day's time we got 24 inches of rain, or a week, even a month of 24 inches of rain in Indiana, that gets to be a lot. However, that's not much for an entire year in these large, vast open areas where we have all sorts of different species and organisms trying to survive. Therefore, you're not going to see areas where we have a lot of large, tall trees. You're not going to see trees that are clumped together. You're going to see them very sparse and spread out because there's not enough water to sustain them. We therefore have these different types of herbivores with very few predators that they have to worry about out in the grasslands. So in the prairies of the United States, we used to be covered in buffalo. We used to have millions of buffalo because there were just large open areas, smorgasbord, if you will, of grasses that allowed them to survive without too many natural predators to take them down. When we go over into Africa, we get these areas called savannas where they get a little bit more precipitation, about 36 inches of rain in a year's time. So, therefore, it does allow for some of these trees, but notice how spread out they are and how sparse they are. There's not a lot of them, and they're not really super tall trees like we have in our temperate rainforests and deciduous forests in the United States. But they do get a little bit more precipitation, so their root systems are able to grow. Therefore, you'll see some larger consumers like giraffes and elephants that can access the leaves on these different trees. Then we make a huge jump, right? So our next biome is where we're looking at the tropical rainforest. Now, tropical rainforests have what is often thought of as the largest amount of biodiversity, the largest number of different species living in it, um, and found close to the equator. So these are going to be hot, wet areas. So when if you talk to individuals like my dad who were in Vietnam and they talk about going through the forest, Vietnam is a tropical rainforest biome. And they just talked about how you were always sweating and it was always hot because the moisture trapped inside of the underneath the canopies of the rainforest, it just becomes constant moisture and can actually be very detrimental to individuals if they don't focus in on their hydration. But when we talk about tropical rainforests, then looking at the equator, that's one of our bases for a tropical rainforest because tropical refers to often being hot. When we look at the other part of it, then we're talking about a lot of annual rainfall, a lot of precipitation. So when we look at the tropical rainforest, then when we talk about areas that are at the equator. So once again, the equator is right in the center of the earth and it's always getting direct sunlight all year long. We don't have to worry about it getting too cold. Once again, in Indiana, we're closer to the North Pole, right? And therefore at times we're leaning away from the sun and at times we're leaning towards the sun, and that's what sets our season. You have a constant season of hotness and summer where the equator is going up and down to about 23.5 degrees. So when I go up, we end up at the line of the Tropic of Cancer. And then when I go down in the southern hemisphere, we have the Tropic of Capricorn. So when people talk about, hey, we're going to go to the tropics, they're talking about really those regions from the Tropic of Cancer all the way down to the Tropic of Capricorn. It's those 46 degrees of the Earth's um, longitude where you're going to find the hottest areas. And where those hottest areas are, that's where your tropical rainforests are. So when we're talking about the amount of precipitation, we're talking about areas that are going to get more than 66 inches of precipitation per year. And that really jumps up in the amount. What that looks like to you and I is 5.5 feet, right? So we don't think about in inches, we don't think about in centimeters, but if you think about 5.5 feet, most of you are not 5.5 feet tall. So in a year's time, you're getting that much precipitation happening in these areas. And not only that, because they're covered in these very large trees, then the water just kind of gets trapped down underneath them and circulates. So it's constantly going to be hot and very humid outside in those regions. So when I start looking at what we're talking about when it comes to trapping that moisture, then these large trees, because there are so many of them, because there's so much precipitation, therefore there's enough variety, then we end up with what is called a canopy. And that's all the leaves of the trees connecting, making basically a roof. If you think about the canopy on Lucas Oil Stadium, when they play football, sometimes it's open and sometimes it's closed. It's the roof of the building itself. And that's what we're talking about. But these tropical rainforests have such a large variety of different organisms and species, and they're still discovering new ones because we haven't been into the deepest parts of the different forests like the Amazon. But we're talking about some incredible organisms. There is a second one, and that is the temperate rainforest. And these are very similar, other than, as we said on our previous day, that temperate means mild temperatures. It's how it's going to change. So when we're talking about temperate rainforests in the United States, we're talking about areas that are a little bit north or a little bit south of the tropic lines, the Tropic of Cancer and the Tropic of Capricorn. But they still get a large amount of precipitation in that year's time. So once again, we're going to be close to the oceans, close to the water. There aren't nearly as many temperate rainforests as there are tropical rainforests. So up above, right above the Tropic of Cancer and right below the Tropic of Capricorn and along the ocean lines of continents is where you're going to find these temperate rainforests. And temperate, once again, means temperature changes and it's going to be much more mild than the tropic regions. When we look at the United States, then we can go over to the far west. We have Northern California, we have Washington and Oregon, and going up into Alaska. The majority of the west coast of Canada is referred to as temperate rainforests. Then you go across into Europe, and they're scattered along, as well as the eastern coast of the Asian continent. But once again, we're talking about 5.5 feet of precipitation. That's a lot of precipitation, right? That's a lot of rain. We don't get that much in Indiana, even though at times we have seasons where it seems like it's never going to stop raining. But once again, we have all of this sunlight, all of these canopies, these tops of these trees, and therefore when you get beyond down closer to the ground, you don't have a lot of extra plants other than some ferns and low ground lying areas. You're not going to see tall weed grasses like we have in our region. But we do have a very large variety of different types of animals that we can see. Animals that have more fur, usually, or more feathers, because some of their temperatures are a little bit cooler compared to the tropical rainforests. But for both of our forests, we talked about the canopy. So part of our fifth grade standards now are talking about the different layers of the forest and the treetops. So when we talk about these regions, we'll see some of these extra trees that are called the emergent layers. So they grow a little bit taller. They're, once again, trees are competing for food, right? Just like you and I compete for food with other animals in our ecosystem. Once again, a tree can only get food if it goes and gets it from the sunlight. So these trees continue to grow larger and larger and larger, and some of them become what's called the emergent trees. They become even larger than the other trees around them because they're fighting and competing for that sunlight so they can make food. The majority of your trees are going to be found in what's called the canopy, right? Once again, kind of like Lucas Oil has a canopy that's open or closed during some games, depending on the temperature outside. That's the roof of Lucas Oil. The canopy of the trees or the rainforest is the tops of the trees that mostly gather together. If you were to be down underneath where the understory is, then you're not going to see a whole lot of sunlight because a lot of sunlight can't get through the majority of these vines and trees because they're constantly competing for the sunlight. It becomes quite dark. This is an entrance area into a path of the Brazilian rainforest. I have a sister that lives down there, and she sent me this picture. But it's amazing as how dark it actually gets as you are walking in the jungle, even though it's in the middle of the day. And now we make a switch into more mild temperatures. So when we look at Indiana once again, we are what is referred to as the temperate deciduous forests. Now, yes, we have grasslands and we have croplands in the majority of our area. But when we look and take a step back and look at the definition of a grassland, grasslands are large, wide, open grass areas where very few trees can grow, but we do have some shrubs, and that's not us. We have some very large trees and forest areas in Indiana. The idea of deciduous, then, it means that the leaves can change colors and fall off. That doesn't mean that all of the leaves on the trees change color and fall off, because the needles on pine trees are also referred to as their leaves. But we're talking about regions that have mild temperatures, right? There's a variation between being cold and hot, but we don't get super cold like the northern part of Canada, and we don't get super hot like the tropics. So we have these moderate temperatures, and once again, that's what temperate means. When we look at the United States itself, and if I would cut it in half, basically the eastern side of the U.S. is classified as a deciduous forest area because we have many, many different trees. You start going west, then you get into the grasslands, then you get into the. So when we talk about deciduous forests and we talk about their temperature changes, right, then we do have some animals that have to adapt to those temperature changes. Sometimes they're going to migrate, sometimes they're going to hibernate, and sometimes they adapt and they grow extra fur, extra feathers in order to survive the colder months. So when we look at deciduous forests, we do have a large variety of organisms that are going to migrate during the winter season, or they're simply going to travel. Then, when it starts warming up, then if they're hibernating, they wake up, they come back out of their dens or their huts, and then we have some animals like the Canadian geese that return because it's become warmer for them. We do have some trees that will stay green. Those are our evergreens, our pine trees, but we are talking about non-coniferous trees, so not pine trees. We're talking about trees that change color and they shed their leaves in the wintertime, all of which allows for a large variety of different organisms that we can find. So these are some of the main animals that we can find in the temperate deciduous forests of the United States. However, it's definitely not all of them. There are many more that could go on. Now we travel north. When we start getting beyond our moderate temperature regions, we get into northern Canada, and it starts getting much colder. When it gets much colder and for longer periods time of cold seasons, then the ground becomes frozen most of the year. With a frozen ground, then our deciduous trees are trees that change colors, lose their leaves, go dormant, or hibernate during the winter, and then start growing their leaves in the spring for their growth season. They can't survive in this region because they have shallow root systems and the ground is frozen. They can't access the water. And then the growth season is much shorter, so they don't have enough time to produce enough food to make it throughout the long winters. Coniferous trees, pine trees, evergreens, whatever you would like to call them. They're also called boreal trees. They have very deep root systems that can go under the frozen layers of the soil and get into the areas of where there is water that is not frozen. So when we talk about these areas, if we're going to talk about where trees are, that's where we're going to see our pine trees, our evergreen forests. And that requires some very different organisms that can survive there compared to the deciduous forests. Once again, these are also known as boreal trees or boreal forests. These only exist in the northern hemisphere. We do not have any of these that go to the southern hemisphere. And the reason being is the southern tips of all these continents still are not far enough south to where it's always going to be cold as you get closer to Antarctica. So in the northern hemisphere, up above the equator, then we have these regions, the closer you get to the Arctic Circle, that it's very cold and only the evergreens can exist here because once again their root systems are deep enough to where the other trees aren't. So when we talk about boreal organisms, right? So boreal, once again, the coniferous trees, the evergreens, then you're going to have some organisms that really have to be able to adapt to being able to eat and survive off of pine cones and the needles of trees and be able to travel to get food and blend in with the different environments. This is a harsher climate, and therefore there's not as much of a variety of organisms that you're going to find here. But we still go further north and we still get much. Now we get into some extreme environments. So going into the furthest north of our continents in the northern hemisphere. Once again, we don't have these in the southern hemisphere because there's no land masses that are close enough to the South Pole, Antarctica, other than Antarctica itself. And that's a desert because it gets very little precipitation. These regions are so cold that the ground is almost always frozen. Therefore, since the ground is almost always frozen, we don't have any trees that can withstand it being this cold and the ground being frozen so deep that the root systems cannot get to liquid water. Therefore, they can't survive. So we are up beyond the boreal forest, the coniferous trees, the taiga biome, to where now it's just mostly open land with some shrubs, with some lichens, and things that can survive these really harsh frozen ground areas. All of these tundra biomes are going to be located right around the Arctic Circle, right below the North Pole. The ground is so frozen that most of the time we're talking about groups of organisms that have to be able to travel. Now that thing in the center and to the right, it is not some kind of dinosaur weird looking buffalo. That is called a muskox. And notice they have very thick fur. They can survive in these cold regions. You have your polar bear who has very thick fur and he can actually go swimming in the water along the coastlines. And it the tundra is one of those regions that it's very challenging to survive, and therefore the population of human beings is very few and far between. And most of them are actually going to be nomadic, which means they're going to travel with the different herds in which they're raising. These areas are so cold because, once again, they're in the very northern parts of our globe. They're along the Arctic Circle. These are very cold regions and once again frozen ground. So when I start looking, I can see these very small weeds growing on the ground and I see different colors. So a lot of these you're also going to find those lichens that are covering the rocks and things, but because there's not enough warm seasons and unfrozen ground, it doesn't go beyond having the lichens and the mosses that are covering the soil. As you're walking along, it's very hard and crunchy from what I understand. No, I've never traveled to these regions. We get very little rainfall. We get about 14 to 16 inches of precipitation every year. Notice 14 to 16 is right above that level of being a desert. But once again, it's also very cold because it's at the Arctic Circle. We have very few animals that can survive in these regions. If I look at most of them, they are going to migrate, right? So they're going to travel into different areas and have to find food. When we talk about these, then we're talking about regions that are all, once again, up in the northern parts of our continent. So, do we ever think that they can go from North America to like Russia and Asia, those northern continents, since they're so far apart? Well, one of the things that we don't often see or think about is how a map is actually focused in on the Atlantic Ocean. If I look at a map that's focused in on the Pacific Ocean, I can see that there is a land region between North America, Alaska, and the eastern part of the continent of Asia, and they're not very far apart. If we look at a map with this type of setup, where we're focusing on the Pacific Ocean, and we look at northwestern Alaska, the furthest city west in the United States is known as Nome, Alaska. And then we have the top eastern part of Russia. Notice how close those are together. That gap is only 53 miles. Now, 53 miles to you and I seems like a long time. I'll put it in perspective for you when it comes to you and I. That's like driving from Jamestown, Indiana, almost to Illinois. But I can't go down 74 and drive 53 miles from Jamestown and get to Illinois. We're about 2 miles short of getting to Illinois. We can drive it in about 45 minutes. So that's really not a long distance. So if you think about it, when we think about Russia being on the other side of the world, we actually have part of our country, right, the furthest west, Alaska, that's less than an hour away from Russia driving. And that seems a little crazy. But people in Nome, Alaska will travel across what is called the Bering Strait, that little distance, just like some of our organisms. If we think about the caribou, there is what is called the Great Caribou Migration every year that the Bering Strait will freeze. Now, unfortunately, because of global warming, the Bering Strait doesn't freeze nearly as often as it used to. But when I talk about a caribou migration, I'm not talking about just one or a couple. I'm talking about a whole lot. It's estimated that there's anywhere from 100 to 400,000 caribou that will travel and migrate together in the northern regions of the tundras. And when the Bering Strait is frozen, they will travel west into Russia, and they will travel east into northeastern Canada, and they will migrate, traveling back and forth, looking for food, sustain all those hundreds of thousands of organisms in their species. That's a whole lot of traveling. But once again, you have this really small area between the continents that if it is able to freeze over, then it allows for that traveling. People in Nome, Alaska, when the Bering Strait is frozen, will actually drive across the Bering Strait on their snowmobiles and go grocery shopping in some of the towns on the top eastern coast of the Asian continent because it's closer to them from Nome than it is any other major city where they can go and get groceries and supplies that they need throughout the winter. All right. For our next day, we're going to focus in on the aquatic ecosystems. We have several different ones from freshwater to saltwater in the deep parts of the ocean. So hopefully you've taken your notes. You should have a couple more minutes left in class. Just behave and relax. Be kind to Mrs. Miller.